In this next step, we'll be making decisions about recording data in ways that will help us answer our questions. This process is also known as data management.
Data management involves making decisions about data. The codebook and frequency distributions are an excellent guide for making these decisions. In fact, many decisions that you make will be based on examining frequency distributions. You will use them often because they reveal things about the data that will be helpful to you.
There are several steps commonly considered when conducting your data management. You may only need to perform a subset of these steps. It is even possible that your variables are already adequately managed and no data management is necessary. In all cases, it is important that you consider each possible decision because it allows you to play an active role in understanding your data and assuring that you are asking your questions in an appropriate and meaningful way.
A first step to consider is whether or not you need to code out missing data. We'll use our young adult smoking project as an example. In the NESARC codebook, you see that the response category 1 means daily smoking for variable S3A Q3B1. And you can read down to see the meaning of other response categories for the usual smoking frequency variable and frequency table. Your data will often include response categories that don't help you answer your question, even though they provide information. For instance, in this variable, we have a response category unknown, coded as a 9. For these responses, we simply don't know how much these individuals smoked, and therefore we don't want to include them in our analysis.
Here's our basic program so far. First, we imported the libraries that we will use. Next, we loaded our data set. You may also recall that to avoid order problems with our frequency distributions, we added code that assures that the variables we are working with are numeric. Here, we subset the data to only those observations we'd like to include in our sample. In this case, 18 to 25-year-old adults who have smoked in the past 12 months. And we named the subsetted data frame Sub1. Finally, we made a copy of this new data frame and named it Sub2. Taking the next step, we are going to set responses of 9 for variable S3AQ3B1 to missing, so that Python disregards these values. We include the following statement in our program. There are actually 3 parts to this statement. First, I'm going to leave the variable name that will have 9 set to missing as is, that is, as S3AQ3B1. Second, I include the original variable name, and third, I replace the missing values indicated by a value of 9 to NaN through use of the NumPy library. NaN is how Python specifies missing data. Remember that whenever you use a variable, you need to tell Python what data frame the variable is inside by using the name of the data frame before the name of the variable. Here we use data frame Sub2, which includes past 12-month smokers age 18 to 25. Together, this code tells Python to create a new variable with the same name, S3AQ3B1, to give the variable the values of S3AQ3B1, but to change the selected observation, that is those with a 9, to NaN. To check that this code accomplishes what we intended, we're going to ask for a frequency distribution of counts on the original variable, that is, before the code that set 9 to NaN, and then we're going to ask for a second frequency distribution of counts for the new smoking frequency variable, S3AQ3B1, following the code that sets 9 to NaN. As you'll recall from our first program, Python does not display missing values for numeric. If we'd like to include a count of our missing data in the frequency distribution, we also need to add the option drop NA equals false, following the sort equals false option within parentheses. Once we save and run this code, as you can see from this new frequency distribution, The 3 usual smoking frequency cases that were set to 9 are now included as NaN. So this variable has been managed.
Let's consider another of the variables in the sample project, S3A Q3C1, the variable usual smoking quantity. Here's the codebook entry for this variable. Usual number of cigarettes is indicated by values of 1 to 98. A value of 99 indicates an unknown response. It's this value that we need to set to missing, since it doesn't measure the number of cigarettes smoked, but rather indicates that we have no information on cigarette use for individuals who are coded as a 99.
The code that I need to add to my Python program first specifies the variable name that I chose. Here again, I am leaving it as is, S3AQ3C1. Next, I include the original variable name whose values I will be assigning to it. And finally, I replace the missing values indicated by a value of 99 to NaN through use of the NumPy library. We also run the frequency distribution for this new S3AQ3C1 to check that the statement we just wrote accomplishes what we intended. When we scroll down to examine the original and new frequency distributions for usual smoking quantity, we can see that the 9 observations that were originally set at 99 are now coded as NaN. So what's next in data management? When we examine the frequency distribution and the codebook entry for tobacco dependence, tab 12 MDX, for our sample project, we see that this variable only has valid observations. That is, 1 equals nicotine dependence and 0 equals no nicotine dependence. So this variable will not require any data management for missingness, and we're set to move forward.
Please note that it is important that you examine each of the variables that you've selected and add syntax to your program that recodes appropriate data as missing. Once you have completed this portion of the data management, the next step is deciding whether or not you need to code in valid data that has been unnecessarily set to missing.